Good morning, good evening, good afternoon. I hope everyone is doing well. Good to see some people here hanging out with the meaty one. Rumble is being weird. Really weird. Because of the denial of service attacks that are taking place. We also, I've had some internet issues this morning. I know many others are as well. Apostle Steve, yep, I got it up, buddy. We're going to hit that first. And then we're going to get into wormholes. So I'd say hi, Apostle Steve. Good to see you. Impish, I really hope you're feeling better. That sucks. It seems like it's hitting you pretty hard. So hopefully you get better soon. The mightiest of all the meats. What's up, greedy bloke? And it looks like we have the lovely Impish over on Rumble. Impish, you stole my Belandris from me last night. I really could have used his help. You know I'm playing with you. So let's just jump right into it. This is fresh. I have not seen this. This is the Pelosi body cam footage, and hopefully we're going to get more. No, I'm just playing with you. Like, if he can help, that's awesome. Hopefully I have him tonight. I finally got my money for my ship, so I can buy my ship now. So that's pretty awesome. Don't tell Belandris. Don't tell him. I want him to be surprised when he sees the SS meat. So let's jump into this Pelosi body cam footage. I have the volume on. The cam
definitely don't want all of here.
There we go.
I definitely don't want all of here. Hello. Yeah. Fucking said 2620, right? No, 2640. Oh, 40. Yeah, it literally said in there. Hi. Hey guys. How you doing?
How are you?
What's going on, man?
Everything's good.
Hi. Drop the hammer.
Nope. Hey.
What is going on right
I'm
now?
not getting an answer on call back.
Bro, oh shit.
Yeah.
Calls in the area that is someone in here.
I got him, Michael.
Edward 14, Edward, send back up, code 3.
Cellophane.
Code 3 back up at 26.
Give me your fucking hand!
Units code
Give me your fucking hand!
40 Broadway for 14 hours.
Edward 14, Edward, send medics, code 3 as well. You got it?
Sorry, 14 number 2, save medic code 3.
Affirmative.
Okay, so I have more questions than answers at this point. Let me see if there's more, because I thought there was supposed to be more. It looks like that's all that's on Twitter right now. When we're told that. Yeah, I thought that was weird. He didn't have pants on, and he was holding a drink. Sorry, guys. I'm just trying to buzz through and see if there's anything else. Oh my God, I need that one. Hang on. Yeah, let's go for it. This is hilarious. So we're gonna watch it. It says first body cam clip released. How is that happening? One, two. What? Opens the door. Yeah. This young lady, the Paul Pelosi body cam footage has been released, and it only raises more questions. What's up, Just Dawn? Good to see you, dear. So it doesn't look like to me that this guy had broken in and blah blah blah. It looks like he's drinking and partying maybe, and this guy gets spooked by the cops. He put something in his pocket too when the video starts, so I thought that was kind of weird. I don't see any additional footage. I guess there's supposed to be additional footage at some point. But this just dropped, 10, 15 minutes ago, maybe. So, yeah, he put something in his pocket and then, wow. Huh. I don't know. What's your guys' thoughts? Why was Pelosi? Right. So, yeah, Vicky T, we'll get there real quick. They just dropped that footage, so I wanted to watch it, and I figured why not watch it along with y'all. Let's watch one more time, just for it.
Yeah, definitely don't want all of here. I definitely don't want all of
It happened so quick.
Hello. Yeah. Fucking said.
Let me try and pause it.
No, 2640. Oh, 40. Yeah, it literally said that. Hi. Hey.
See, he put something in his pocket They both say, "Hey guys," and they're both smiling.
What are you doing?
Oh, yeah.
What's going on, man?
Like, he has a drink. He's in his underwear.
Everything's good.
Hi.
No, everything's good. And they're smiling at each other.
Drop the hammer.
Nope. Hey.
What is going on right
I'm
now?
not getting an answer on call back.
Bro, oh shit.
Just crossing the area that he's coming in, yeah.
I got him, Michael.
It seems like bro got spooked. Seems like he got spooked. Because everything's good. Like, this is the important part. This 10 seconds. Or whatever.
2620, right? No, 2640. Oh, 40. Yeah, it literally said that. Hi.
guys.
How you doing?
Oh, yeah.
What's going on, man?
Everything's good.
Hi. Drop the hammer.
Nope. Hey.
What is going on right
I'm
now?
not getting an answer on call back.
Bro, oh shit.
Like, I don't. Like, out of context, that completely makes no sense whatsoever. Like, he's way too happy and friendly with the hammer guy, 100% K lover. Yeah, well, I think it was that he is probably like, they've tried to report. What's up, Belandris? Like they've tried to report, I think that he certainly has kind of that vagrant status, and he got spooked when the cops came. Like, the cops came and he got spooked. Yeah, that's also a very interesting perspective, because why didn't they have some kind of security or police? Or, I mean, this is the Speaker of the House. This is the third most powerful person in the entire world, arguably. It didn't look like a break-in to me. It looks like that guy was intended to be there. And Paulie P got caught, and the guy got spooked. Well, maybe you do. Maybe if you're on substances and, you know, the guy just ratted you out is what you're thinking. And so you're thinking he called the police on you and he ratted you out. So you smack him with a hammer and think you're going to run away. I think we need more. I don't know that we're going to get it, but I didn't think we were going to get that either. So what do I know? I do know something about wormholes. Do you disagree, Stevie? Like, what's your explanation for it then? I'm just trying to have a conversation. I'm not trying to. No, always one hand. Two hands are for the ladies. One hand on the hammer. I'll get to wormholes as soon as Stevie answers me. Same friend, Grandnan was in DC, no security, night off. A friend over for a nightcap, and friend a guy to. No, nothing makes sense. Okay, we're getting into wormholes now. Like, we're off that topic. Which tab is this? This is this one. So, does anybody know anything? What's up, Beaver, over on Rumble? Does anybody know anything about wormholes? I'm sure the concepts came up. And the reason that I brought this up is it's all been theoretical until Google just released that they artificially made a wormhole for a quantum computer. So we're going to go through and we'll start with what are wormholes, my opinion on them, and then we'll go to the article about the quantum computer. And honestly, it terrifies me. It is actually in the thumbnail. It's that picture on, I think it's on the left. Well, I can bring it up. There's my... Come on. All right, so let me bring that up and then... Yep, no problem, Doc. So it's this thing right here. This is a quantum computer. Isn't that just kind of creepy? And we'll get into it more. That's Google's quantum computer. So, and I believe that's the processor. So, when we get into quantum physics a little bit more and we get into the quantum realms, I have a friend that knows a lot about quantum computing, and maybe I'll have them pop on, hang out. I want that one. So what are wormholes? The weird tunnels through space-time are still hypothetical. And this is a last year article, so they would have thought so at that point. This is the general thought. First, you have to conceptualize the multiverse, or the time theory universe. And it's like a piece of paper that's... I think they have a better picture in here. Sorry, I'm going to fly through. If not, it was the other one. It's the other one. I believe. Okay, so this is what the theory is. That you can't move faster than the speed of light, but if you can bend space-time, which is space-time, time-space, is a construct in which space looks like this, and we can actually bend space-time. So the idea is you could bring space together and create a wormhole to bypass. So instead of going 15 light years around, we go one through, if that makes sense. Incorrect, impish, but I love you. So let's get into... We'll use this one. Maths have predicted wormholes, but for now, these bridges through space remain hypothetical. And this is a very recent article, but not... Right. Yeah. No, you're totally fine. I just, I'm always open to different thoughts, and I like to have a discussion around things. You know that. So, drugs make people do weird things, but we're past that. So, what's in between the wormholes, though? That's a good question. They think that physicists and these type of people often think that it's a fabric and a void. So they think it's a literal fabric and a void. So space-time is literally, that's why they call it the fabric of time, because they think it's just a single layered fabric on a timeline. So like you would do for a PowerPoint presentation or something of that sort. Like you would actually put a timeline. That's what they believe that space-time is. It's an actual timeline, and location correlates with time. So if I go 15 light years into the future, I'm also 15 light years worth of distance measurement away. if that makes sense. And if anybody has any questions, absolutely. Yeah, theoretical fields that compress P-Beaver. Hey, Mystic. Oh. Hey, Mystic. What's up, Snafu, too? Yeah, the idea is to punch a hole through it. So you'll see this in some sci-fi. They'll actually compress or pull in the fabric of time, like kind of roll it up, so we can go faster than the speed of light. The math works out. The math actually does work out for wormholes. And it actually does work out in theory now, too. So, as we'll get into. It's giving me chills. Well, put on a blanket. So, the wormhole theory postulates that the theoretical passage through space-time could create shortcuts for long journeys across the universe. Wormholes are predicted by the theory of general relativity, which is largely inadequate to explain. But be wary, wormholes bring with them the dangers of sudden collapse, high radiation, and dangerous contact with exotic matter. So, why am I missing? I think that's the point that we'll get into. So, sudden collapse. So, they would be incredibly unstable. Incredibly unstable. Can you send it to me, Belandris? So it'd be incredibly unstable. I don't get where they think there would be high radiation, but okay. And the exotic matter. They're talking about dark matter or antimatter, because theoretically there would be both those things present. So, and the other issue with it is, how do we direct it? Because at now it doesn't seem like we have a great way to direct it either. Exactly. P-Beaver on Rumble. Just like Event Horizon, fold a piece of paper in half. I think you meant. Fold a piece of paper in half and poke a hole in it. And then you have your wormhole. Correct. Right. And it would be unstable. So we'll get into it. But wormholes were first theorized in 1916, though it wasn't what they were called at the time. While reviewing another physicist's solution to the equations of Albert Einstein's theory of general relativity, Austrian physicist Ludwig Flamm realized that another solution was possible. He described a white hole, giggity, a theoretical time reversal of a black hole. Entrances to both black and white holes could be connected by a space-time conduit. So he thought there were a portal, and one was in, one was out. Get rid of that. I just want to get rid of the ad. And in 1916, that probably sounded like a good idea. Now, I think it's a terrible idea. Obviously, if you go into a black hole, you would get spaghettified and ripped apart atom by atom. Very racist, Snafu. So, in 1935, Einstein and physicist Nathan Rosen used the theory of general relativity to elaborate on the idea, proposing the existence of bridges through space-time. These bridges connect two different points in space-time, theoretically creating a shortcut that could reduce travel time and distance. These shortcuts came to be called Einstein-Rosen bridges, or wormholes. Scientists are horrific at naming things. I know you did. I didn't say that. Oh, you're getting a cast on the wrist finally? Actually, I don't know what the hell this video is. Oh, it's just an ad for their stuff. Okay, we're not going to watch it. Or is it? Your pictures. Okay. I said that finally. Greedy. Hang on 1 second, guys. Sorry. My apologies for that delay. I was freezing, so I had to turn on my heater. It's so cold in the D. The whole thing is very hypothetical at this point, said Stephen Sue, a professor of theoretical physics at University of Oregon, told our sister site, Live Science. No one thinks we're going to find a wormhole anytime soon, but we did. Wormholes contain two mouths with a throat connecting the two. Useful. According to an article published in the Journal of High Energy Physics 2020. The mouth would likely be spheroidal. The throat might be a straight stretch, but it could also wind around, taking a longer path to move than a more conventional route might require. Now, I lived in Sanford for a while, and it's so warm. It's sticky. All right, Greedy. Enjoy your dinner, I believe. Einstein's theory of general relativity mathematically predicts the existence of wormholes, but none have been discovered to date. A negative mass wormhole might be spotted by the way its gravity affects the light that passes by. They also believe that there are tiny microscopic wormholes spread throughout our everyday life. So nothing that you could get something lost in or anything like that. But they've theorized that there are tiny little wormholes spread throughout, and one could be, one could be right next to you, and you would have no idea. Certain solutions of general relativity allow for the existence of wormholes, where the mouth of each is a black hole. However, a naturally occurring black hole formed by the collapse of a dying star does not itself create a wormhole. Science fiction is filled with tales of traveling through wormholes, but the reality of such travel is more complicated, and not just because we've yet to spot one. The first problem is size. Primordial wormholes are predicted to exist on microscopic levels, about 10 to the negative 33rd centimeters, so very, very small. And this is what I'm talking about. However, as the universe expands, it is possible that some may have been stretched to larger sizes. Hey, Linda, good to see you. So the thought is that they're very small, very small. Let me Let me see if I can get something to compare it to. It's probably very small. Well, how big is an atom? That's a good question. So it's smaller than an atom. So where's the picture? Okay, so this says that an atom is 10 to the negative 8. The nucleus is 10 to the negative 12. A quark is 10 to the negative 16. An electron is 10 to the negative 16. So we're talking about smaller, centimeters. So we're talking about half the size of an electron. So very, very small. Hey, Jude, good to see you. Very, very small. Half the size of an electron. So another problem comes from stability. The predicted Einstein-Rosen wormholes would be useless for travel because they collapse quickly. You would need some very exotic type of matter in order to stabilize the wormhole, said Sue. And it's not clear whether such matter exists in the universe. But more recent research found that a wormhole containing exotic matter could stay open and unchanging for longer periods of time. Exotic matter, which should not be confused with dark matter or antimatter, contains negative energy density and a very large negative pressure. Such matter has only been seen in the behavior of certain vacuum states as part of quantum field theory. If a wormhole contains sufficient exotic matter, whether naturally occurring or artificially added, it could theoretically be used as a method for sending information or travelers through space, according to Life Science. Unfortunately, human journeys through space tunnels may be challenging and nearly impossible. We're so unbelievably many steps away. Hippish. Yeah. I do a lot of things. I jump on just about any rocket in the country right now. I would not volunteer to go through a wormhole. I think we're made to. Again, I'm a very firm believer in simulation theory and the simulation hypothesis. I think that we are meant to go linearly in time and not meant to cheat it or go back. I think we'd all like to. I think it's a cool exercise to think about. But I think, unfortunately, like we are a linear time species, and we go from here to the next, and yeah. So I don't know how much I buy that that we could ever do it. So the jury's not in, so we just don't know. Now we could send. Sorry to get off tangent. We could send information through it. We could, use it as a conduit and send a bunch of ones and zeros. You'd go back. What's the one thing you'd go back to? Like, if you could go back and do one thing differently, what would it be? You're damn right I did, Stevie. Like, everybody put it in chat. Like, what's the one thing you would go back and do if you had an opportunity? It doesn't have to be personal. for you personally, like what's the one thing that you want to do? Like, for instance, the one thing that I would like to do is I would like to go back to the late 1700s, early 1700s. And yeah, you can go for it, Belandris, or go put it on Rumble. So the one thing that I would do would be go back to the mid to late 1700s with my knowledge and experience. And I think we could one, change the way that certain documents were written to make it more impactful for the Americans. And I think we could advance scientifically very quickly. That is so selfish, impish. Cycle's over, so I don't recommend it. What cycle? What are you talking about? I missed something. Simulation was created due to the unseen war. The king will return for the war is ending. Okay. Yeah, then I'd be your sugar baby. No, what do they call the... I don't know what they call it. That's not my grift. The jury is not in, so we don't know. Physicist Kip Thorne, one of the world's leading authorities on relativity, black holes, and wormholes, told Space.com. But there are very strong indications that wormholes that a human could travel through are forbidden by the laws of physics. That's sad. That's unfortunate. But it's the direction in which things are pointing. So I tend to agree with them on that one. So we have a couple different... We have some pluses. One form of the wormhole... One form of wormhole relies on the curved space-time to function. To us all three-dimensional beings, it appears flat, but curves in the fifth dimension or greater to fold back on itself. That would be really cool. Say it. Say it, impish. So, and that takes into account that we have to... So... Hang on. So it doesn't... Here we go. So has anybody heard of the Kaluza-Klein theory? So this is a fifth dimensional bottle, or a proposed rendering of a fifth dimensional bottle. So it's a closed system, but these points don't intersect. Do you see how there's a... Like, this is the mathematical representation of a fifth dimensional object. Yeah, you're like 7 feet tall. That's not going to happen, buddy. Hell yeah, Jude. If you make it through a wormhole, how do you know that you made it to the other side, or that you're still in the meaning of the universe as we know it? You wouldn't be. We would have to leap an understanding of things so much that it would be unrecognizable. The Kaluza-Klein, yeah, they did. I wonder if you'd strike me. We could maybe watch it. Let me look it up. Did you send me that other one? Too big guy? I like Action Lab. I think he does good work. Let's see. Let's see if I can figure it out where. Spinning liquids make great telescopes. I haven't seen that yet. I have to go back and watch that one. Hang on. I apologize. I could have had that one. Hemisphere, delayed choice experiment. Time travel really possible? No, it's not. Every action reversible? No, it's not. Well, theoretically, we should be able to put it together. Okay, cool. Thanks, buddy. Let me just type in Klein. Oh, here we go. I want it short, though. Okay. Maybe he can. We'll watch this video. Just trying to get it up and ready. Sometimes I have problems getting it up and ready. All right, so let's watch this guy for a minute. Flyer. Let's see. Yeah. Lockheed would have to design an entire jet. But, yeah, I mean, I think being humble is huge. So. I might have seen it. I just don't.
I'm going to be showing you what a real 4D Klein bottle looks like.
Okay, so this
I
is
have
the
here
4D
a Klein bottle in three dimensions.
Excuse me.
Klein bottles are really neat because supposedly they have no volume. Now this is a Mobius loop. Mobius loops are cool because it's a one-sided surface. So the Mobius loop has one side and one boundary. And I'm right back to where I started from. But in 1882, a mathematician named Felix Klein had an idea. He thought, what if you taped two Mobius loops together and got rid of the boundary and had only one side? Now, what he was imagining is this, a Klein bottle named after him. So the Klein bottle has no edge, it's boundary free, and it has no volume as well.
See, it's so, I don't think this is the fourth dimension. I think fourth dimension is space-time, and I think this would be a fifth dimension. So I disagree with the fourth dimension representation, and I know it's a point of many people in the space. So
you know what else doesn't have a volume is this beaker right here. So how does this beaker and this Klein bottle both not have a volume? Now a cylinder has a volume, but that's because you can measure the length of it. So you could measure the volume of this by imagining that there's a surface on the top here. But when there's no actual surface at the top, mathematically it doesn't have a true volume because this shape doesn't enclose a volume. You'd have to tell it where the top is. Well, this beaker here is actually topologically the same as a disc. It has
pausing for screw tube.
Two sides, this side and this side, separated by an edge. But a Klein bottle is different. It has no edge, no boundary. So you can see if I follow my finger around the edge, I end up on the inside of it. But if I keep going, if I can move my finger through the inside, you'll see that I could follow it back, come through this area here, and then I would end up on the outside of it if I could pass through the surface here. Now, Klein bottles are really interesting to look at, and they look really difficult to make too. And there's a lot of videos about them saying, can you fill a Klein bottle? Is it possible? But interestingly enough, this isn't actually a Klein bottle. This is actually what they call a 3D immersion of a 4D Klein bottle. The problem that we have is that it intersects itself, and a real Klein bottle doesn't intersect itself. So let me show you how it's possible to get rid of this intersection here if there are 4 spatial dimensions. For example, let's say we have...
Pausing for effect.
Have this 2D person living in 2D space. So because they live in 2 dimensions, they can only see something on the surface of this paper. If I put my finger here, they don't actually see my hand or arm or anything, but they just see a little circle right where my finger is touching the paper. So let's say we have this shape in their 2-dimensional world. If there's only 2 dimensions, if you want this shape, you can only have a shape that intersects itself. You can't have anything different. But if we had an extra dimension that this could loop back on itself without going through itself, then we could get this shape, but it wouldn't have to intersect itself. So what we could do is just pick it up off of this 2 dimensions and lift it up above itself. So from 2 dimensions, it would look like this. So you could just lift it up into the 3rd dimension.
This explanation is so crazy. Like, it's so hard to conceptualize, so hard to grasp.
Like this. So what we were able to do is get it to cross over itself by lifting it up into the 3rd dimension, not only using these 2 dimensions. But you can see if we view it from above, it looks like it intersects itself. And that's the same reason why we can get a 3D version of a 4D Klein bottle, because it looks like it intersects itself. But to see the true Klein bottle, we have to be able to go up 1 more dimension and see it not intersecting itself. So in 2 dimensions, now what this would look like would be this shape. It would look like it just ended because this part is the part that went up into the 3rd spatial dimension. But because they can only see what's in the 2 dimensions, then they can't see the part that went into the 3 dimensions. So keep this in mind when I show you what a 4D Klein bottle looks like. I'd like to thank PCBWay for sponsoring this video. PCBWay is a one-stop solution.
But PCBWay is a good deal.
This is an app called 4D Toys. And how it portrays 4 spatial dimensions is that it shows you the 3 spatial dimensions, but on the right-hand side here, you have a slider bar. And this slider bar allows you to slide up and down through the 4th dimension. So it's the equivalent of if you were in 2 dimensions, you could slide up and down in that 3rd dimension there. So you could see any plane of it at one time that you want to. So we can still only see what's happening in 3 dimensions at one time because we live in a 3-dimensional world, but you can choose what 4th dimensional plane you want to view that in. So because we're viewing everything in 4 dimensions, they're not called the shapes that we're normally used to calling things. For example, a square isn't a square, it's called a tesseract. So for a tesseract, that's a 4th dimensional cube. So we can slide up and down in the 4th dimension and we keep seeing a cube. If it were a real square, what would happen is as soon as we start sliding up and down in the 4th dimension, the square would just disappear altogether. It can't.
Yeah. So again, this is just insane. Like insane. So
not be up in that 4th dimension at all. But depending on how you turn the tesseract in the 4 and 3 dimensions, then you're going to see different parts of that cube at one time. The same thing with the sphere. If you have a 4th dimensional spheroid and you slide that up and down in the 4th dimension, you'll still see a sphere, but that sphere will change size. So now we can understand how we can view 4th dimensions using this app here. So let's see what a true Klein bottle looks like. Not a 3-dimensional immersion of it that we're used to seeing that has an intersection. So we're
no, it just makes it just moving beyond 3 dimensions. Right. And just to be clear, they're mathematically, they have devised that there are 10 dimensions and we can barely grasp 3. I disagree with the 4th. I think this is 5th dimension, but just for the sake of argument.
Only going to be able to see slices of the Klein bottle at one time. But what we can see is this intersection point. You can see that it intersects itself right here. But now we have a new spatial dimension that we can move that intersection up and over away from it. So I can push this button here and it will unintersect it. So it will show us a true Klein bottle. So the surface can pass through itself without making an intersection or a hole. Notice how this 3D image of the 4D Klein bottle looks very similar.
So voodoo. So I take it back, because if I went back to the 1700s, they'd probably call me a witch and kill me. I think that's just wishful thinking, Jude.
to the 2D image of the shape I showed before that went up into the third dimension. You're missing a piece of it. So the piece that's missing right here is going into the fourth spatial dimension. So it doesn't intersect itself. And thanks again for watching another episode of the
Thank you, Action Lab, for your footage. I appreciate it, sir. Fair use, of course. Let's watch this short clip from Belandris.
Relativity, yes, we can't break the law of relativity. We can go around it. The ship doesn't really go faster than light. What it does is it creates a dimensional gateway that allows it to jump instantaneously from one point of the universe to another light years away.
How?
Well, it's difficult to, it's all math.
Try us, Doctor.
Right, well, using layman's terms, use a rotating magnetic field to focus a narrow beam of gravitons. These, in turn, fold space-time consistent with Weyl tensor dynamics until the space-time curvature becomes infinitely large and you produce a singularity. Now, the singularity...
Layman's terms.
Well, fuck layman's terms. Do you speak English?
Imagine for a minute that this piece of paper...
Excuse me, that's Vanessa and that's mine.
Attractive piece of paper represents space-time, and you want to get from point A here to point B there. Now, what's the shortest distance between 2 points?
I like to go to point
Straight
B.
line.
Wrong. Shortest distance between 2 points is 0, and that's what the gateway does. It folds space. So
Oh, wow. I forgot to pause it. But
point A and point B coexist in the same space and time.
exactly.
When the spacecraft passes through the gateway, space returns to normal. It's called a gravity drive.
How do you know all this?
I built it.
This story tells
I want to build one. Okay, so the wormhole entrance looks like a black hole. There may be an accretion disk made of matter falling into it. In a rotating black hole, the singularity occurs as a ring or a line rather than a point. This is what provides the gravity required to sink the wormhole through space-time. So think of it like a gravitational whirlpool. Keeping the wormhole open against the gravitational forces causing it to collapse requires some negative energy or anti-gravity we have yet to discover and may not exist. Quantum effects with curved space-time may be able to violate the average null energy condition, keeping it open. The exit looks the same as the entrance. Unlike a black hole, from which nothing can escape, forces and even matter may be able to exit a wormhole. Theoretically, but probably not. Yeah, that's what I thought. A couple more. Wormholes are not only to connect two separate regions within the universe, they could also connect two different universes, or different multiverses, or similarly, some scientists have conjectured that if one mouth of a wormhole is moved in a specific manner, it could allow for time travel. But ladies and gentlemen, we know time travel is impossible. You can go into the future or the past using traversable wormholes. Astrophysicist Eric Davis told Live Science. But it won't be easy. It would take a Herculean effort to turn a wormhole into a time machine. It's going to be tough enough to pull off a wormhole. I don't think it's possible. But, I mean, theoretically feasible. However, British cosmologist Stephen Hawking has argued such use is not possible. I agree with Stephen. A wormhole is not really a means of going back in time. It's a shortcut so that something was far away is much closer, according to Eric Christensen from NASA. Although adding exotic matter to a wormhole might stabilize it to the point of human passengers could travel safely through it, there's still a possibility that the addition of regular matter would be sufficient to destabilize the portal. So what's that saying is we'd have to put so much negative matter in to keep it open and actually void that space-time, that it could be difficult or nearly impossible to send additional matter through. So you couldn't throw a human through, because that would be additional matter that you'd have to account for to keep it open, and it would almost have to be on a microscopic level, because you would have to balance the matter with the antimatter, or the gravity with the negative gravity, or so on and so forth. Today's technology is insufficient to enlarge or stabilize wormholes, even if they could be found. I mean, we're easily 50,000 years, I would say, from being able to use wormholes, if ever. And the way we're going, we'll probably destroy ourselves before then. However, scientists continue to explore the concept as a method of space travel, with the hope that technology will eventually be able to utilize them. What's up, Greedy? You have a good dinner? You will need some sort of super advanced technology, Sue said. Humans won't be doing this anytime in the near future. Which Albert Einstein's theories proved correct. Read NASA's 10 blah blah. Nope. I'm good. And that's a black hole. And the thought is that black holes could also transport, but you wouldn't make it. It's worth a shot. I mean, everything's worth a shot. I'm down for trying everything. What if we approach at a 45-degree angle? Well, the gravity well would bring you much like a black hole. So this accretion disk, this circle around the outside, is called the accretion disk. I hope you can see my mouse. I can't see it. So this ring around the outside is super gravitational. So it would actually suck you down into it, because it would be such an attractive force. What? Will they lead to a singularity? Steve. Sure. We can do that. It leads to a singularity, so the mass continues to compile and it gets more massive and more compacted. We don't know what happens when it reaches critical mass. I don't think that. Yeah. So that's my perspective on that. Well, I'm very curious. Very curious. Anytime that word comes up, then I need to know more. So that's a brief article about that. Now, why it came up. I was trying to see if this was worth it. It's pretty much the same thing we just read. But, however, there is I know damn well they're going to copyright me. I can't even in good conscience do that. Okay, we're not gonna watch that video because I can't do another copyright strike right now. What if we do a Russian? It would have to be such an incredible amount of armor, and it wouldn't be traditional metal. Thanks, buddy. Does involve matter and antimatter. Well, that's the thought, that antimatter could theoretically stabilize the walls of the portal. But then you'd have to be really careful, because if matter and antimatter connect, they annihilate and release energy. So if you even had, so we're in the future, so we probably won't have combustion engines, but if you had combustion engines that produce fuel and produce some kind of exhaust, even that exhaust interacting with the antimatter would cause annihilation, more energy than a nuclear warhead, and the portal would close, destabilization of the portal. So anything that is being secreted by the ship would cause destabilization. So we could do that. No, I love the what ifs, and they're never dumb. Don't ever think they're dumb. I enjoy the thought process that goes into stuff. Like, that's the whole thing. So can we think past it? Can we? And I don't know everything. It's impossible to try and learn everything. So I just try and pass along the knowledge that I do have to help other people try and understand it, because then we get further. I'd rather have 30 minds than one, and if we can process it, and people have different points of view or different ways of looking at stuff, then I think it's incredibly vital to moving forward with it. So nobody brought me popcorn last time. Belanders, you're being dirty. All right, so why this came up. So the unprecedented experiment includes the possibility that space-time somehow emerges from quantum information, even as the work interpretation remains disputed. So Google has built a quantum computer. Quantum computers use quantum packets with quantum entangled particles to flip on the same binary, the 1 and 0 that we currently have. But they gap space-time, and it's supposed to be quicker. So so we'll read this. I know for a fact because I know somebody that worked on it. So yes. No, I don't generally believe Google, but yes, I do. Absolutely. They have to have something spectacular. And like we saw with that internet theory, it's not what they say it is, and it's not what people think it is. Very limited results. They just curate the most popular. That's how science works, not in a vacuum, in a group with ideas. Exactly. More than you know happens when somebody says, oh, well, da-da-da, and then people like my brains roll that around and turn it into something that's, I haven't actually, I strongly dislike Apple, so I stay out of any Apple news, and that gives me a bias, and I probably shouldn't, but potentially, but there's actual science behind it. And other people are doing it as well. IBM's doing it, Apple. Yeah. I trust Apple or Google, or both of them, about as much as I trust Bull Andrews, which is not very much. Love you, buddy. Researchers were able to send a signal through an open wormhole, though it's not clear what sense the wormhole can be said to exist. So it can't see it. It's too small. I hate Apple, but their phone is my fave. Okay. They do have, not to get off on a tangent, but they do have fantastic computers for processing images and videos. When I was in college and doing photography, they were far, far superior for image processing, running programs like Photoshop. So, yeah, Jude, that's the whole point. Engage your brain. Like the brain's a muscle too. We have to use it. Physicists have purportedly created the first ever wormhole. Well, that just makes it more fun, Jude. A kind of tunnel theorized in 1935 by Albert Einstein and Nathan Rosen that leads from one place to another by passing into an extra dimension of space. The wormhole emerged like a hologram out of quantum bits of information, or qubits, stored on superconducting circuits. By manipulating the qubits, the physicists then sent information through the wormhole, they reported today in Nature. The team, led by Maria Soropoulou of the California Institute of Technology, implemented the novel wormhole teleportation protocol using Google's quantum computer. A device called Sycamore, housed at Google Quantum AI in Santa Barbara, California, with this first of its kind quantum gravity experiment on a chip. As Soropoulou described it, she and her team beat the competing group of physicists who aimed to do a wormhole teleportation with IBM and Quantinuum's quantum computers. Jesus, pick a different name. See your next comment? The next comment is Belandris. Yeah, I agree that the gap is probably closed. I bought this. I forgot what this is, but so I bought a really nice gaming computer, and I used to build my own computer, and I was like, no, I want a really nice gaming computer, and I've loved this thing, and it's kept up with everything. So everything that I do. I mean, you can't argue with their new processors. They're insane what they can do compared to Intel. I'm an Apple fanboy. Yes, Stevie, there are so many reasons. That's probably why we're in love, because opposites attract. But there are so many reasons I dislike you, but I still like you. So it's confusing the hell out of me. When Superlu saw the key signature indicating that qubits were passing through the wormhole, she said, "I was shaken." The experiment can be seen as evidence for the holographic principle, a sweeping hypothesis about how the two pillars of fundamental physics, quantum mechanics, and general relativity fit together. Physicists have strived since the 1930s to reconcile these disjointed theories. One, a rulebook for atoms and subatomic particles. The other, Einstein's description of how matter and energy warp the space-time fabric, generating gravity. The holographic principle, ascendant since 1990s, posits a mathematical equivalence or duality between the two frameworks. It says that bendy space-time continuum described by general relativity is really a quantum system of particles in disguise. Space-time and gravity emerge from quantum effects, much as 3D hologram projectors out of a 2D pattern. Oh, no, we're not watching that. I thought it was like a short embedded video. No, I think Einstein was, I think he was overrated, but yeah, I think he did some fantastic things as well. I'm not getting him down. I'm just saying it's interesting how we're polar opposites on every single topic, and you know, yeah, and that's the thing. Yeah, that's where we got ours too. So, and it was more than I've spent on a computer, but I love it. Snafu is a no-no word on Xbox? Huh. Is that why you're cardboard or whatever? I don't get Steve down.
Gay!
Indeed, the new experiment confirms that quantum effects of the type that we can control in our quantum computer can give rise to a phenomenon that we expect to see in relativity, a wormhole. The evolving system of qubits and the Sycamore chip has this really cool alternative description, said John Preskill, a theoretical physicist at Caltech who was not involved in the experiment. You can think of the system in a very different language as being gravitational. Gravitational in the general sense of the word, not the updated definition. That's awesome, Snafu. I didn't know that. Well, I know. I mean, I have to walk on eggshells sometime, but we're learning to deal with it. To be clear, unlike an ordinary hologram, the wormhole isn't something we can see. While it can be considered a filament of real space-time, according to co-author Daniel Jeffries at Harvard University, lead developer of the wormhole teleportation protocol, it's not part of the same reality that we and the Sycamore computer inhabit. The holographic principle says that the two realities, the one with the wormhole and the one with the qubits, are alternate versions of the same physics, but how to conceptualize this kind of duality remains mysterious. So they're saying that I get what they're trying to portray. So there's duality. So there's one system in which this computer exists, and then there's one system in which a wormhole and qubits exist, and we're trying to meld the two together. Well, the biggest thing that Apple does that frustrates me, right, you can't uninstall it, one. Two, they take planned obsolescence to a whole new level. Like they brick devices if they're too far. Opinions will differ about the fundamental implications of the result. Crucially, the holographic wormhole in the experiment consists of a different kind of space, time than space. Time in our own universe. Of our own universe. It's debatable whether the experiment furthers the hypothesis that the space-time we inhabit is also holographic, patterned by quantum bits. I think it is true gravity in our universe is emergent from some quantum bits in the same way that this little baby one-dimensional wormhole is emergent from the Sycamore chip. Of course, we do not know that for sure. We're still trying to understand it. This is about it again. There's Einstein. So we're not going to read the same thing again. Yeah, that's the same. So it just explains the same thing. We could probably... Oh, this is helpful, though. Graphic. Absolutely. Exactly. You are such a liar. We know that's not yours. Yep. It's all made up. It's all theoretical. And some people will fight you on it. Some people will fight you on it. And that doesn't make any sense because we have to be open-minded and understanding of different perspectives if we're ever going to make any leaps in science. Because this hard stuck on this is the way it's got to be, or this is the way I know it is not helpful to the furtherance of science. Yep. Okay. Just relax, Stevie. Go take a nap. Do you want some tea? I've determined that time travel is not possible, and I showed you why. You go take a nappy. So, holographic wormhole. A quantum computer has created the equivalent of a wormhole, a shortcut between 2 points in space-time. The wormhole is a higher dimensional view of the machine's quantum bits or qubits. I don't know if we should be looking at some of these qubits on YouTube. 1. 7 bits simulate entangled sets of particles known as SIC models. An 8th qubit is swapped into the left model. So superposition, it can be up or down, both or neither. So, all right. So they put it into SIC, and then it transports over here, supposedly. The qubit information spreads among the particles on the left. So this essentially flips the pole of all these bits on the left. This thing could come up with concept brings it into existence. The actor was taken. I think that we can. Certain people can bring things into being by just thinking of them. I think certain people have that power. Even with Daddy Elon money, time travel is not possible. I do not watch Star Trek. I never have. I've never enjoyed it. Talk about pole shift maybe next week. That is true, Greedy. But we're on a linear timeline. I talked about that earlier. Somebody was eating fish and chips. I'm not a huge Star Wars fan either. My kids and wife are, so I've seen most of them, but it's not my, like, it's so hard to take it seriously because none of it makes any sense. Like, I'm not one of those people that can just suspend belief and watch a movie. Like, I have to figure out, is it possible? I'm not a fun person to watch a movie with. I'm aware of that. That's why I stopped watching movies. A magnetic pulse rotates, the qubit states. This is equivalent to sending a negative energy shockwave through the wormhole. So, I have seen that. That was pretty funny. The information unspreads to a single particle. Repeated measurements show that the teleportation is occurring. So they're basically flipping poles. So I think this is more quantum entanglement than a wormhole, but yeah. And that's the Seporia. And I think that was it because they're just explaining. Oh, this is the sycamore chip. So it's all these tubes. One thing about I can't do fantasy, man. Like, that's what I'm talking about. It has to make sense. It has to be logical. Like, one of my favorite movies is, so I like Fantasia. I like Mr. Brooks. I like, what's the other movie that I like? Oh, I can't remember what it is right now. I must not like it that much. But there's like 3 or 4 different movies that I actually enjoy. I like the Airplane movies. Does that count? Airplane 1 and 2. So the lightsaber is not possible. It's not possible with our technology. It's not possible with any technology. Like, it's irrationally impossible. So it's hard for me to suspend belief because I'm such an analytical thinker. I have not been to Fermi Labs. I would like to at some point, but I have not. We have the Enrico Fermi power plant in Monroe, Michigan, though. So. No, there's not. It is. Red October. There you go. No, it's October Sky. October Sky. Best movie of all time. Nope. I hate Harry Potter. I hate Harry Potter. I like October Sky. I like Sum of All Fears is another good movie. But I couldn't think of the name of it. This is probably my favorite movie. Favorite movie, right there. Sober Sky. Great movie. So this is your quantum chip. Back to the thing. Yeah, let's go. I did like Interstellar, because there's a lot of concepts that are reality. October Sky? No. You've never seen it? Go watch it. I wonder if it's on Amazon, because then I could do a watch party on Twitch. I'll look into it. Because I don't like them. I don't like Harry Potter. I just don't like it. Yeah, gay wizard, blah, blah, blah. The chick turned out cute, but you can't like her because she's like 10. So it seems creepy. Like, can't do it. Let's do it. Where is Fermilabs? Actually, it's no, but I don't know. Bativa. Like, I know, I just don't know, like, where. And they don't say. Stop. Hang on, I'm going to turn it off now because it's driving me nuts. Sorry about that. It doesn't help me. Yes, Emma Watson. And yes, he is. I think they all are. That's Fermilab. I would love to go. Lamont. Lamont where? Like, what state? Because it's not where I thought it was. But that could just be me. Oh, Illinois. Okay. Bativa, Illinois. Damn, that's not far at all. I don't think. Let me see how far it is. Sorry, I'm on a tangent. We also have a particle accelerator at Michigan State University now. In East Lansing. Might be closer. I got invited up there by Dr. I forget her name. I have a picture with her though. I got invited up there, but I haven't been up there yet. Everything takes time, and then COVID. It's only 5 hours. Oh, why did it go away? Oh my God. Stop it. Yeah, about 5 hours. It's on the other side of Chicago. But yeah, let's go. So these have to be cryo-cooled or super-cooled. So you have super-cooled fluid that comes through these to super-cool the chip because it gets so hot from all the electrons. And that is that one. Pine Street in Batavia. I'll swing by and get me Gary. I'm not going to Gary, though. I went to Gary one time about 10 years ago, and it was terrifying. Yeah, did we learn anything? I think that wormholes absolutely exist. I think they're in a higher dimension than we have capability of understanding. I think we'll never be able to actually utilize them for travel or quote unquote time travel, especially. And I think even if we can utilize them for some purpose, I still think it's tens of thousands of years away. I think they're a cool theoretical thing. And discovering them would tell us a lot about our universe and the makeup. That's my take on wormholes. Wormholes are not like black holes in the way that they won't swallow up the Earth. So I don't have as big of a problem with wormhole research as I do with black hole research, because theoretically, and they've made a couple at CERN, but theoretically, if they made one large enough, it would keep consuming it until it grew enough to eat the Earth. So, theoretically, eat. That's funny, Blanders. I just saw your thing. You're not far behind. What? Somebody hates all good movies. Yes. I told you I'm not enjoyable to watch a movie with. I'm not a fan of movies. Yes, I prefer white to blacks. The blacks are just so destructive, greedy. The black holes. Yeah. That's not with a nasty snowstorm. That sounds terrible. Oh, did I teach you that, Linda? But all right, y'all. Thank you so much for joining me today. I know there's a lot of trial coverage going on, so. Oh, I meant what I said. It's a joke, YouTube. Thank you guys so much for stopping by. I appreciate it. And hopefully you learned something. We will have a show tonight. I have no idea what we're covering. If you have any suggestions, shoot me a message. I'm sure we'll have something, and I'll look through some stuff. But other than that, I hope you guys have a great day, and I will talk to you guys later.